In this series of 3 demos, we'll look at different approaches for scaling big IP management, from manual config with LTM policies and iRules to automation with Ansible and Terraform, and bring it together with a GitOps example. We'll wrap up with key takeaways and best practices. From analysts to customers, we hear that infrastructure as code and pipeline-based automation are quickly becoming a best practice, not just a nice to have. For organizations managing big IP, infrastructure as code or IAC delivers massive benefits. Automated, repeatable processes, reduce misconfiguration, speed up deployment, and allow teams to scale easily and consistently. Here's a quick look at the use cases that we're exploring, starting with the fastest time to value on the left using LTM policy and iRules, both of which can be configured directly in the Big IP service portal or via API. As we move to the right, Terraform and Ansible offer more flexible, repeatable automation at scale. And finally, on the far right, we have a full GitOps with the Jenkins CI/CD pipeline, where Big IP config is stored in Git and can be triggered to update our infrastructure. One note is that all of these approaches can also leverage F5's Application Services 3 or AS3, which provides a fully declarative model for configuring advanced app services on Big IP with a single JSON declaration. AS3 integrates seamlessly with tools like Ansible, Terraform, or GitOps pipelines. In the first demo, we enable server maintenance mode on just one of 2 sites sharing the same virtual server. First, we use an LTM policy to redirect traffic for the target site to a maintenance pool, and then we replicate the same behavior using an iRule. We'll start in the Big IP service portal by creating a new LTM policy for routing traffic to a maintenance pool. Let's give it a name and then proceed to create a maintenance rule. We need to give our rule a name and then need to specify the conditions that will be matched in order for our rule to be applied to this policy. In this case, we have 2 host names attached to a virtual server, and we'll set the HTTP host name to the matching criteria. We'll also need to specify the action to be taken when the condition is matched, which is to forward the traffic to a maintenance pool. Now we can publish this policy, and once done, need to go into our virtual server under Resources in order to enable this specific policy. As you can see here, we have both iRules and policies, and out of policy, we'll select the newly created one. And now we can go and test. And once we run a curl, we see that the server is in maintenance mode, and the other one is working just fine. Now we can disable this policy and just as easily. We can see that the hostname traffic is now routed to the operations pool. We can do an equivalent configuration by using an iRule. You can click create and then name and paste the script that matches the hostname to route the traffic to the maintenance pool. And all we have to do now is enable the iRule on the virtual server, click manage, and then select the newly created rule to be enabled and click finish to complete this configuration for our virtual server. We can now go into console and again try the curl command and see that the hostname traffic is routed to the maintenance pool. In the second demo, we will look at 2 most popular automation options for Big IP, Terraform and Ansible. Terraform is declarative, where a desired end state is defined in .tf files, and it builds and modifies infrastructure accordingly. Ansible playbook execution, by contrast, is imperative, where it uses step-by-step configuration. Despite these differences, both frameworks are often used together in modern workflows, Terraform to provision and Ansible to configure and manage services once the infrastructure is live. We'll use Terraform this time to configure the LTM policy for maintenance, and we'll also add Ansible to the workflow to configure an iRule to prevent path traversal attacks. This shows how either tools can be used for automation tasks based on customer preference, or both can be used together if desired. We start with a curl command to show that both of our hosts are routing traffic normally. And now we want to get started by running Terraform init script, followed by an import of a state from our Big IP. This ensures that we're adding to existing config, and Terraform plan shows us what will change. It generates a preview of what gets applied when we run this next command. And in just a few seconds, the Terraform script creates the new LTM policy and enables it on our virtual server so that the traffic to our specified host is going to a maintenance pool. And as we can see it here in the service portal under policies for our virtual server, the policy is applied. Now let's use an Ansible playbook to automate first creating an iRule and second binding it to our virtual server. The iRule shown on the right here contains a logic to prevent path traversal, which is a common attack vector. Let's say we have all these virtual servers and we want to automate enabling an iRule for all of them. We'll run the Ansible playbook, which adds one iRule and then loops through all of the virtual servers that we specified to bind that iRule to each server. The end result, as we can see here under Resources, is that the iRule is now active. To see it in action, let's run a path traversal script against all of our virtual servers, and you can see that our requests have been blocked. We can also look at the BigIP logs to verify that iRule is active and working as intended. In this final demo, we connect the dots by extending Ansible with Jenkins GitOps to enable scaling of the app and adding a waiting room feature. First, we trigger a CI/CD pipeline to add more nodes in BigIP to meet demand, and then we attach a custom iRule that routes extra requests to a waiting room. Using both together illustrates how GitOps, Jenkins, and Ansible can streamline IAC configuration of BigIP. We start with just 2 nodes, and using Jenkins, we'll run a scale-out pipeline, which adds additional nodes and also creates a new iRule and applies it to our virtual server. Clicking Build Now triggers a manual run of the Ansible playbook. Note that the Ansible playbooks are using the secrets stored securely in Jenkins to connect and interact with our BigIP. We can see this under the list of nodes in the service portal, and you see that there are 6 new nodes that have been added. And we also can see that the new nodes are also now our standard operations pool. These are now ready to accept traffic, and just to make sure that the new iRule is created, we can see it here, which is also applied to all of our virtual servers. Picking any one of the new servers under Resources, we can see that the rule is active. Now we can see this configuration update in action. Let's simulate a long-running operation. This could be, for example, ticket sales or something else that takes a long time to process, which is why you might need a waiting room in the first place. This demonstrates a length of a typical transaction, which has to complete before the next request is processed. So now when we run another transaction, because the first one isn't completed yet, any additional requests are automatically routed to a waiting room, which will refresh periodically until all requests are processed. Similarly, we can trigger a scale-in operation in Jenkins to remove the additional nodes. This can be run on a timer, be a part of a CI/CD pipeline, or be triggered manually as we did here. With GitOps model, you can separate infrastructure config code from the secrets and variables specific to our environment, as we just shown here, which adds a ton of flexibility and helps scale operations. Across all 3 demos, we showed how to get started with scaling configuration using LTM policy and iRules, extending that with Terraform and Ansible-driven automation. This illustrates different approaches to F5's BigIP automation to scale operations and improve operational efficiency. Learn how you can use LTM policies, iRules, Terraform, and Ansible in your IAC initiatives today.